All right, so this is the last unit of the review. Let me get the camera fixed a little bit. There we go. All right, so the last thing we're going to talk about is the last unit of the year, and that was similar and congruent triangles. Okay, so first thing we're going to talk about is similarity. Okay, so what are the three postulates used to prove similarity? So those are going to be our acronyms. Okay, so the first one is going to be side, side, side. The second one is going to be side, angle, side. And the last one is called angle, angle. Okay, so remember, for similarity, sides are going to be proportional. And we'll do one in just a second. And angles are going to be congruent. Okay, so if I'm looking at this first problem right here. Oh, okay, so what they're saying was side, side, side. So that means that all three of my sides are going to be proportional, but they're going to be proportional by the same scale factor. So if I multiply one side by 2 to get my new triangle, that means I'm going to multiply all my other sides by 2 to get the new triangle as well. Same thing for my sides for side, angle, side. The only difference is it's only 2 sides instead of 3 sides. And then it's going to include a congruent angle in between my 2 sides. And then my last one, AA, just saying that to be similar, they have to have at least 2 congruent pairs of angles that are corresponding. So that way we can say that they are similar. Okay, so if you just have angles written there, they're either going to be AA or not similar. If you just have sides, it's going to be either side, 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 or not similar. Okay? All right, so number 44. It says, if triangle ABC, so if triangle ABC is similar, so remember this little squiggle, that means similar, to triangle DEF, then name all the corresponding parts, congruent angles, and proportional sides for my triangles, okay? So remember, the placement matters. So where they are in the name, that matters. So if I say angle A is the first position. So that means that it's going to be congruent to angle D. And then the same thing is going to be for angle B. Angle B is in the second spot, so angle B is going to be congruent to angle E. And then angle C is going to be congruent to angle F. Okay, and we can do the same thing with sides, but remember they're not going to be proportional. They're not going to be congruent, they're going to be proportional, so they're going to be similar. So I would say side AB would be similar to side DE because AB is first 2 and DE is the first 2 as well. Then I'm going to say side BC is similar to side EF. And then my last ones are going to be CA is similar to FD. Okay, so just whatever order that your triangles are named in, that is where their corresponding sides and angles are located. Okay, so this one says solve for x. So we know that these triangles are similar because they share this angle and I have these parallel lines. Okay, so we can actually set up a proportion to solve for x. So there's 2 ways we could look at this. We could look at it like this. We could say whatever I'm multiplying this side by to get this side is going to be the same for this side. So let's go ahead and do that. So if I say to multiply something by 4 to get 8, I'm going to multiply 2. So I'm going to multiply 2 to this side as well. And 5 times 2 is 10. So 10 equals 2 plus x. And then I'm going to subtract 2 from both sides. So x would equal 8. Okay, so that's one way. Or we can set a proportion. So we could call this triangle 1, triangle 2. So I know that triangle 1, I have a side 4. So 4 is going to go with its corresponding side of 8. So 4 over 8 will equal 5, the same triangle needs to be on the top and bottom. So 5 and 4 are on the same triangle, so 5 goes on top. And then second, its corresponding side, it goes on the bottom, so 2 plus x. And then I can cross multiply. So that gives me 8 times 5 is 40, equals 4 times 2 plus x. So remember, when we do the 4, we have to distribute to both parts, the first and the second. So I get 40 equals 8, 4 times 2, plus 4 times x, so that's just 4x. Right? Now I'm going to subtract my 8 to the other side. So that gives me 32 equals 4x. 4x equals 32. And then I'm going to divide by 4. So x equals 8. So both ways, we got the exact same answer. We just did it a little bit differently. So whatever makes more sense to you, you can use it. Just don't forget it. Okay? All right, we're on to the last couple. Okay, there we go. So it says a person is watching a geyser and wanted to be able to see the top. He put a mirror on the ground and backed up until he could see the top 7.5 feet away. Okay, so I know it's really hard to see this picture, so I'm going to write, he's talking about, here's the mirror, here's the dude, he's standing here, and it's 7.5 feet away. If the mirror was placed 45 feet away from the geyser, and he is 6 feet tall, so here's the 6 feet tall, here's my first triangle, and then we want to know how high did the geyser spray go. So here is, so there are my two triangles. That is what I'm solving for, x, the top of the geyser, how tall it went. Okay, so these are similar triangles because I have a right angle, and then this angle and this angle will be the same because of my mirror. Okay, so we want to do, so let's go ahead and say that this is triangle 1, this is triangle 2. I'm going to set up a proportion, but I'll show you the other way you can do it as well. Okay, so I'm going to go ahead and say that x over its corresponding side, so since this is a height, I want the other height. It's going to be 6 feet. So x over 6 equals, and then I'm going to go ahead and do the bottom, right? I'm going to do 45 because I want to keep the same triangle on the top and the same triangle on bottom, and its corresponding side is 7.5. Right, so this was triangle 1, this was triangle 2. And then this was corresponding sides, and then corresponding sides, okay? So now I'm going to cross multiply. I know there's a lot of lines there now. So I got 7.5x equals 6 times 45. So I'm going to go ahead and say that 6 times 45 is 270 equals 7.5x divided by 7.5 divided by 7.5. So that gives me x equals 36 feet. So the geyser got 36 feet high. Now another way you could look at this is you could say that I know whatever I multiplied this to get to this is the same this to this. So I could say 45 divided by 7.5. 45 divided by 7.5 is 6. So I know that anything, if I multiply this by 6, it will also get x. So 6 times 6 would be 36, and that would also equal x. Okay, so either way works. All right, now we're getting on to congruence. So congruence means they are the same. So these are going to be the same, the triangles. They're going to be the same shapes, same size. So my 5 postulates are going to be side, 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 angle, side, angle, side, angle, 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 side, and HL. Okay, so 8, those are my 3 that are going to be congruent, okay? So remember, this time your sides are also congruent. And your angles are congruent. okay? So just like with similar triangles though, the way we order it matters. So if I say if triangle ZYX is congruent to triangle ABC, then segment BC is congruent to what segment? BC is this second part right here. So it's going to be congruent to the second part as well. So BC would be congruent to YX. Okay, and then same thing. So if it's triangle QWE is congruent to triangle IOU, then angle E is congruent to what angle? So angle E is right here, so it'd be congruent to angle U. So angle E is congruent to angle U. Now we're going to use the triangle postulates, the congruence postulates. So given the picture, you can prove that triangle RST is congruent to triangle XWY by what postulate? Okay, so I'm going to look here. I'm only going to use one triangle for this. Okay, so I am just looking at how they're congruent. So I have an angle here, a side in between, and then another angle. So it's going to be angle, side, angle. So whatever the order is in the picture, that is the order that you are going to write it, okay? So make sure you're paying attention to the picture and you're just kind of moving your way around it. You might also want to double check that the triangles are actually congruent. I know that since R is first, it should line up with X. So if R is congruent, then X should be congruent to each other. They should be congruent to each other. S is next, so I know it should be congruent to W. They have two arcs, so they are congruent to each other. And RS should be congruent to XW. RS is congruent to XW, so we're good. They are congruent by angle, side, angle. All right, so this next one says, by what postulate are the two triangles congruent? So it only gives me two things. It gives me sides. I have a side is congruent to this side. And I know that this angle is congruent to this angle. Now, it doesn't label anything else, but we should always know something is always congruent. And that is my vertical angles. So these angles right here, just like when we were doing Unit 4 angle relationships, we have two lines crossing. So when two lines cross, those angles across from each other, they are always congruent. My vertical angles are always congruent, okay? So I'm going to go around my triangle, and I have an angle here, and a side. So I have angle, angle, side. So a lot of y'all were asking, well, how do I know it's not angle, side, angle? Because what if I started here and I went this direction? It would be angle, side, angle. You can always look at yourself and ask, here are my angles. They're both touching this side. Is this the side that's congruent? If it's not the side that's congruent, then it's got to be on the outside because it's not between my two angles. It's not sharing that side with both the angles, okay? This side is only touching one of my congruent angles. So it's going to be angle, angle, side, not angle, side, angle, okay? So this next one, it tells me this side is congruent to this side is congruent to this side. So we want to, given the picture, can you prove that triangle ABC is congruent to triangle CDA? And yes, we can, because when I have two triangles put together like this, we can say that AC is congruent to itself. Let's go ahead and name it like this, AC, so CA. Okay, and that's by reflexive property. You won't have to prove on the test, but just good to know, reflexive property. Okay, so that means that this side is congruent to itself. So these two triangles, I have a side, I have another side, and I have a third side. So these triangles are congruent by side, side, side. Okay, so last page of the review. So given the congruent statement, give the congruent statement as well as the postulate proving the triangles to be congruent in the following images. So first thing we're going to do is we're going to give the congruent statement. So that's saying triangle. So let's start at J. I'm just going to go ahead and start at J. So triangle J, L, K. And this is going to be congruent to triangle. And since J has no angle and it's on the side with one tick mark, I want to do the same thing on this side, the angle with no arc and one tick mark. So that would be O. And then I'm going to go to the 90-degree angle because I went to the 90-degree angle here. So O to N, and then up to M. So I know triangle JLK is congruent to ONM. Now, it doesn't matter where you would have started, right? I could have started at K and then decided I wanted to go to J. That is fine, but it would have been the same order, right? If I did KJL, KJL, and it was still would have been MON. So the order is the same. You could start at different places, but the order will always be the same, okay? Now, I have a side here, an angle here, and then this side is here. So I have a side, angle, side. So side, angle, side. Okay, so the next one says, give the congruent statement as well as the postulate that proves the triangles to be congruent for the following image. Okay, so I know that this side is congruent to this side, and I have a right angle and a right angle. Okay, I also know that AC is congruent to itself, okay, because there is my, they share that side. So if I start my triangle as A, B, C, okay, so be careful, right? I have to start at C because A is the side that has no tick marks here in between this one that shares the side. So I need to do the same thing. C is the side that has no tick marks here and then shares the side. So I'm going to start at C, and then I'm going to go to my right angle because I went to my right angle then, so D, and then I'm going to end at A. So triangle ABC is congruent to triangle CDA. All right, so this one's a little tricky in that I have another side, and then I have an angle. So I have side, side, angle. Side, side, angle is not congruent, but these are right triangles, right? We have a right angle, so this is a right triangle, right angle, so right triangle. So if you do have side, side, angle, you can double check. Are they right triangles? If they are right triangles, do you have your hypotenuse, which is the longest side of my right triangle? It's the side across from my 90-degree angle. So here's my hypotenuse. Here's my hypotenuse. So AC is the hypotenuse. Okay. And then do I have another leg? So do I have another side? And yes, I do. I have another side here. So in this case, my triangles are going to be by HL. So be careful, right? Not every right triangle is congruent by HL. You need the hypotenuse and you need another side length, okay? All right, last question. It says, the diagram shows a triangle and its image after a rotation about the middle, rotation about the point midway between B and E. So point midway between B and E. So that's my point of rotation. It rotated. Okay. So write anything you know must be true. Okay. So there's a lot of things we could say are true. I know that. Okay. So let's assume. It doesn't say, but assume these triangles are congruent. Triangles are congruent. Okay, so if I'm rotating it, right, because we haven't changed the triangle. If I say rotate, I'm just moving it. So it's the same triangle, it's just been moved. Okay, so if I'm rotating it, I want to see. So I know 63 is here and 63 is here. Okay, so that's a good way to start off. So that means if I rotate this, I know ED is 16, so that means AB is 16. So AB is equal to 16. That's something I know. And then here's A. So it would go with angle D. So I know that angle D is also equal to 45 degrees. Now, I give you two angles here. So that means we can find out more stuff. We can say what the third angle is, right? So 63 plus 45. It's 8, 10, so 108. 180 minus 108. That's borrow, so 7, 10, 2, 7, and 0. So I know angle C is 72 degrees. Angle C equals 72 degrees, which also means that angle F is also 72 degrees. Okay, so I know that. Now I can't find any other lengths because these aren't right triangles and I only have one length. So I'm done here. That's all the things I can figure out. Okay? And you are now done with the review. Good job. Make sure you study over this for your test, whenever your test is for next week. And then come into tutorials if you have any other questions about this. All right.